we start by seeing that there is 2 to the x here, and if we were to break the first term down, 2 to the 2x is like having 2 to the power of x all squared. It's like having 2 of them multiplied together. So we could see that that's a similarity, and so if we can recognize this, if we can see that there's a 2 to the x in both, one is squared, the other isn't, that's like a quadratic. So we're going to solve this as a quadratic. We're going to make a let statement, and let's see how that works. So we let another variable that we haven't used yet, maybe y, be our instance of 2 to the x, and so we'll replace 2 to the x with y. That leaves us with y squared, because 2 to the x was our y in the first term, minus 3y, this little dot means multiplication, plus 2 equals 0. Now we can just factor this. We could see the two numbers that add to -3 and multiply to 2 are -1 and -2. So we have y minus 1 times y minus 2 equals 0. And now we could say y equals +1 and y equals 2. These are our solutions. But this isn't quite done yet, because now we actually have to go back to our original let statement, because we said y was equal to 2 to the power of x. So now we're going to replace y with our 2 to the power of x, and we're going to actually solve for x here. Solving for x uses exponent rules. So remember, anytime we see a 1, that's like having exponent of 0. So we can see here x must equal 0 because they have the same base. On the right hand side, we could see we have exponent of 1 here. Therefore, x equals 1. So we have our solutions for x finally.
Yeah.